So I've just finished the overall power schematic for this gas sensor project, and I'm working on the micro now. As you can see, it's still very bare bone. I'm not sure if this is the correct way to do it. I have seen people do it, but I'll need to look into that. But essentially, these are all the decoupling caps that are supposed to go in between the VDDA and VDD. So it's supposed to be one of each. So, one 4.7 microfarads and 200 nanofards. I'll probably just put them on the line itself to make it easier to understand, because even I could just got confused. Moving on to here, the main schematic. The power schematic, sorry. Very simple compared to the last project called micro USB, which is powering this battery charger. So we're going for a lithium polymer battery, not 1.8, I think it's 1800 milliamps, which is a lot for this project. I don't expect it to use it a ton. So we've got this coming in here. This is going to go through the coupling pack. Capacitor powered LED. This will signify that it is charging the battery. Programming resistor here to set our maximum charge current, so we go max to 500 milliamp. I need to check the battery app to ensure that I'm not going over the top or whatever. It should be fine anyway, but always good to double check. So this is a fairly simple battery, one cell battery charger. You just take it from the reference circuit. So I have the reference circuit here. It says lithium ion, but you can say lithium polymer battery charger as well. Very simple, nice and easy. It gives a whole bunch of information on how this works as well. And this is what you usually do with these types of things. Always look at the typical application as well. It might have also for future, so to give all them how to calculate the values. Here, PCB layout. So when you do your layout, follow this as close as you can, because this is optimized by the manufacturer. Come out here, it's a output decoupling capacitor, and this is where it gets interesting. So this should be really VUSB. So really what happens when VUSB is plugged in, so this is a P channel, so this is always conducting without anything applied to its gate. When something is applied to its gate, it switches itself off, so this can go through here and power the rest of the system. But this is this is just current limiting. This is just to ensure its known state. Always good to pull down and pull up depending on your application. Moving on, so regardless of what happens, we've only got this going in or this going in. Going into here is a simple buck boost converter. I've got put test points around here, as you may have noticed, because when I do produce the board, and I will do some inevitable testing, I have some references to say P ground is a high switching ground as specified in the datasheet. I've put this 0 ohm link because I'm not sure how to connect this. I've said in the datasheet that it will bypass it in certain conditions, so to go through, it just shoot straight out apparently in certain conditions. So I've put that just in case because I'm unsure. It's better to be safe. Feedback, this is a fixed one, so I don't think you need a voltage divider. It's got it internally. Now, of course, you could check. It's called voltage programmer. So I believe this is fixed anyway. Voltage comparator. Directly for a fixed output version, so that's alright. Connect the 22 capacitor or 47. And this is why you should always read the datasheet correctly, as per my video a while ago. To P ground, so we need to make sure we need to connect it to P ground. So I will change that later. It's good to always look at the datasheet. So a regular buck boost, I chose a buck boost because your battery will degrade over time if you don't, not degrade, but go start max 4.2 volts and it can go as low to 2.5, 2.7 volts, I believe. So you need to keep that at 3v3, which is our main power source for the system. So fairly simple power schematic, nothing too complex or mind-boggling, I'd say, compared to the last one. Decided to keep it simple, actually finish this one. But the key takeaways from this: read the datasheet as per usual properly, double check things, read how the application works. Don't just blindly follow the typical application circuit without knowing anything. And if you're unsure of certain things, just put a 0 ohm resistor in, and it gives you that flexibility to change or reroute, whatever it is. Maybe you don't need to connect, maybe you need to connect it, and there you go. So nothing much else to cover. I'm steadily working on the macro. Hopefully that'll be the next one I've got lined in, if not another firmware type video, which I'm working parallel to, but looking all good so far.